Hi folks, so in this video what we're going to do is we're going to complete this question here, which is based around a supermarket kind of checkout little, I suppose, pictorial view here. And it's a question from the 2024 Junior Cert Graphics paper. It was question 5A on the paper. Now the question itself actually would have maybe stumped a lot of students, okay, because they wouldn't have maybe seen it come up in this format before. But this question actually is based around the area of transformation geometry, and it is specifically to do with translations, okay. So what we're going to do here now is we're going to complete the question. We're just going to have a little read of it. So it says here, the image across shows a supermarket checkout, okay? So you can see here, here's the supermarket checkout where the items would run along the belt here at the top. It says, shown below is the elevation and plan of the checkout. So you can see here we've got the XY line. There's the elevation sitting above the XY line and the plan view looking down on top of it. So if I was to position my arrows here, I'm just going to get a different pencil, a little bit darker. That technically there would be the arrow for my elevation, looking in this direction where I see this face, and I see the kind of red surface here. And then the plan view is when I'm looking down on top of it. Now it tells us two boxes, A and B, are on the belt of the checkout. So we've got box A in the plan view here, and that's the elevation of box A, and you can see that they're in line with each other. And I've got box B in the plan view as well, and the elevation. And you can see there's a slight difference between box A and box B. Well, obviously box A looks like a square, box B is a rectangle, but with box B it seems to be kind of tilted at an angle, okay? And that's okay, but just so we're aware of that. Then it tells us boxes A and B move with the belt until box A reaches the line L1 in plan. So you'll see here, this is the direction, so if you had something here, it would move along the belt until it hits this line right here, that line there. And that line in the plan is this line here, L1. Okay, so they want the boxes A and B will move along the belt until it reaches the line L1. So that's the line L1, okay, in plan view. So essentially they're just moving in this direction horizontally, really easy. So let's move box A. Box A was originally here, now we're going to move it until it hits its line L1. So the direction of movement is literally horizontally, so that will move across, and I'm going to project points A here across as well. So they would simply move across like this. Now, this edge here, let's say I was to number that, and I'm going to number it 1, 2, 3, and 4. Well, essentially, this edge here, which I've labelled now as 1 to 4, will be the first edge as it moves along, okay, will be the first edge to actually hit the line L1. So 1's new position is now over here, 4's new position is right there. Now, how do I find the position of 3? Well, it's really easy. All I need to do is take the distance on my compass from 4 to 3. Make sure it's the right distance. Okay, and then I'd put it over here. Put it onto the new position for 4, because the distance from 4 to 3 has to stay the same. So now its new position here is 4. The new position of 3 is here. Okay, so now we have 3, and directly underneath 3, because 3 to 2 is a vertical line, there's 2. Okay, and just switching out here, just getting a better pen just so this is a little bit more visible. So on our sheet, this is what it would look like. This guy out of the way. So the new position for box A is here. Really easy. So box A is after moving, and that's the position of box A. It has moved from this position over to here. Okay, now that it has moved in plan, it's also going to move in the elevation view. Okay, so in the elevation we also have to move it, and this is an area that lots of students left out last summer. They may have done it down here but forgot to do it up here in the elevation. So if it moves in plan, it has to move in elevation. So it's going to move in the same direction. So in elevation, it's simply going to move horizontally across like this. And it's the same principle, normal orthographic, lines will transfer up, okay, actually, sorry, it needs to go up the full way, and then edge 2 and 3 would also come up, okay, and in elevation, that's what it'll look like. So let's heavy that in as well. Obviously in the day of a test, you're using your own pencils. So there's the position of box A in elevation. Now, this is really, I suppose, we've moved it along. This part here for box B is where the translation is going to kind of come into effect, something that you would have learnt in class. So like box A moving along in this direction, okay, moving in the direction of the pencil going in this direction, box B is also going to move along it in that direction. So if we break down box B, it's got 4 points. All those points are going to move. So this one is going to move horizontally. This point here is going to move somewhere along that line. This point and this point. The question is, how far along does it move? Well, it has to move the same distance as box A moved. So how do we work out that distance? Well, all we need to do is we can take one of the distances here. I could take the distance from 4 to 4, 3 to 3, 2 to 2, or 1 to 1, because they will all be the same distance, and I proved it here. So if I put my compass on point 4 here on the original box A and move it out as far as here, where its new position was, well, if I put that on 3, you can see there that will be the same. If I put it on 2, that's it there, it's the same. Now if I put it on 1, same. So all the points on box B are going to move that distance. So I can take a distance off of box A, how much it's moved, and it's going to put it onto box B. So now I'm going to find this point down here. So I put my compass on the point, swing an arc. Put my compass on this point, swing an arc. Compass on this point, swing an arc. And compass on this point, swing an arc. Now that's one way, and simply then all we have to do is connect up those points. Now what I would often encourage a student to do here is look at the relationships of the lines. See that line that I've just drawn there now, which is, I suppose, representing this edge here? Well, what's the relationship between this line and this line? They're parallel, so you could do a little bit of sliding set squares just to make sure you're 100% accurate. So I'm actually doing sliding set squares here now, sliding it across. Yep, and it's working out fine. And then I want to get this one, I'm going to connect them up. And then once again, what's the relationship between this line and this line? They're parallel. So in the plan, I'm going to make them parallel by doing sliding set squares again. And you can see there is my box B. So I'm just going to heavy that in now. So that's the position of box B in my plan. So I've now done B in plan. Now that I've done it in plan, I have to bring it up to the elevation. So the edges are going to move, and as you can see, when we're looking in this direction at it, we can kind of see this face here. If you look at the pencil here, as the pencil is looking at the object, okay, the original object before it moved, I can technically see this face here as I can see this face. So that's why I'm seeing them both here. So that front edge, and then I've got this face here at the side. So it's going to be the same thing up in elevation. So first of all, the height is going to transfer across because it has to stay the same height as it moves along. And then all I'm going to do is I'm going to bring up this line. I'm going to bring up this point, which is in line with the one at the back, you can see there, and then this point. That's the position of my box, and you can see it's the exact same, but all I'm going to do this time is heavy in this. You can see there they didn't have it heavied in fully because that was in front of it. Realistically, that should actually be in hidden detail. And there we go. There is our box B in elevation. And that is all done by using the method of a translation, which comes under the topic of transformation geometry, guys. Okay? Hope you found it helpful, guys. That's the question complete. Okay.